The third planet from the Sun in our solar system is Earth. It is also the only planet on which life may exist. But what if the Earth suddenly began to rotate at the speed of light? What would happen to us? Keep in mind that not everywhere in the world the Earth spins at the same rate. Similar to how its speed at the equator is 460 mph and will eventually drop to 0 mph as we get towards the poles. Therefore, if the Earth suddenly begins spinning faster, the sea level will increase too high, causing water to continue flowing from the equator to the poles of the Earth. We won't be able to breathe easily, and it will also have an impact on the environment because the amount of moisture in the air will rise. Our communication system will be destroyed as a result of the loss of satellite synchronization in low Earth orbit. So if the Earth spins faster, the impact that is produced will be worse. The form of the Earth will shift, continuing to widen at the equator until it becomes a flat disk if the speed of Earth's rotation approaches that of light. Time will move more slowly and eventually come to a stop as a result of the extremely fast rotational speed. The shortest day since the 1960s, according to scientists, was June 29, 2022, when the Earth rotated more quickly than usual. The Earth has reportedly been rotating more quickly since 2016. 2020 saw 28 of the shortest days ever seen in the previous 50 years, according to The Guardian. Despite the fact that Zotov and other researchers will present their findings and theories at the Asia-Oceania Geosciences Society conference this month, experts have not yet been able to pinpoint the exact cause of the increased speed. The duration of the Earth's days has fluctuated before. Days on Earth were less than 19 hours, according to scientists, more than 1.4 billion years ago. Weather patterns are influenced by Earth's rotation. The spin of the Earth has an impact on tides as well. Would the climate become totally unstable if we were to speed up this rotation? There would be some noticeable weather changes. There would be a lot of moisture in the air. In areas close to the equator, dense fog, clouds, and persistent rain would be typical conditions. It would fall backward on you. Instead of dropping, water vapor would ascend in the atmosphere. The Earth's crust would start to flatten at the poles and bulge near the equator at a speed of 11,000 mph, or 24,000 miles per hour. Huge earthquakes would tremble the Earth. Our days would be cut short if the spinning speed was raised by 0.45 mph. However, it was only for 45 seconds. You may not even be aware of the change. Sea levels would rise by a few centimeters or a few inches, even with this little increment. Water in the region of the poles would move towards the equator. A day would only last roughly 22 hours if the acceleration were increased to 45 mph, that is 100 miles per hour. It would be a significant change if sea levels were different. At the equator, the oceans of the Earth would rise by 9 to 20 meters. However, if we spin faster, the situation would become more disastrous. At the moment, if you weigh 150 pounds at the Arctic Circle, you could only weigh 149 pounds there. This is due to the increased centrifugal force produced as the equator rotates more quickly to traverse greater distances than the poles. Your weight would decrease much more if the speed was increased. Ocean water would start to gather at the equator because of the increased speed. Within a few days, the water around the equator would become a few inches deeper at a speed of 1 mile per hour. The equator would begin to submerge at 100 miles per hour higher speeds. According to Fratchek, the islands in the equatorial region, northern Australia, and the Amazon basin would all be submerged. Thousands of gallons of water would be drawn towards the center of the Earth by the centrifugal force. If the speed were increased just a few more miles per hour, millions of people would be forced out of their homes, and numerous low-lying locations of the world, including New York City, Venice, Mumbai, and many others, would be fully submerged underwater. Convection and winds are primarily created by the unequal heating of the planet's surface, not the rotation of the Earth. Nonetheless, the Coriolis effect affects the directional shifting of these winds. The circles of convection would constrict as Earth's rotation accelerated, potentially increasing the frequency of cyclones, hurricanes, and tornadoes in the atmosphere. Adds Fratchek, I believe that everything in the equatorial region would be covered with water. With the exception of the highest mountains, such as Kilimanjaro, or the highest summits of the Andes. The Arctic Ocean would be considerably shallower because the extra water would be drained from the poles, where centrifugal force is lower. A rise in the Earth's rotational speed might have a variety of effects, from more earthquakes and tsunamis to shorter days. While the Arctic ice may melt extremely quickly, flooding many populated areas of the Earth, people may be floating through the air, weightless, in Central Africa. The Moon's presence, however, actually slows Earth's rotation because it absorbs some of Earth's energy each year and moves a little bit farther from the planet. It is believed that the Earth's spinning speed has decreased by around 1.4 milliseconds in the last 100 years. If this is used as a benchmark, it will take roughly 50,000 years to extend the length of a day on Earth by 1 second. It would take a sufficiently enormous object to strike Earth for its speed to rise significantly, and this would have many other effects as well, including the destruction of the crust and extremely deadly earthquakes. Let's simply rejoice that our planet seems to be rotating at the ideal rate for the time being. Moreover, if the world rotates at a speed of around 17,000 miles per hour, the centrifugal force near the equator would be equal to the gravitational force. Following that, we might experience reverse rain, says Fratchek. Water droplets may begin rising in the atmosphere. The spin rate is susceptible to millisecond-level changes due to earthquakes, tsunamis, huge air masses, and melting ice sheets. Earth's rotation is accelerated if an earthquake eats some of the planet's surface, somewhat decreasing the planet's radius. Large air masses can have the opposite impact, slowing our spins just a little bit like an ice skater who does not pull her arms in when she should. The rate at which the Earth rotates also varies over time. After a massive object collided with Earth, the Moon formed around 4.4 billion years ago. According to Odenwald's calculations, our globe was then likely flattened into a football shape and spinning so quickly that each day may have only been 4 hours long. The Moon's gravitational pull on Earth has slowed down our planet's rotation by around 3.8 miles per hour every 10 million years since the Moon's birth. Therefore, it is far more likely that Earth's spin will continue to slow down in the future rather than increase. Will this ever occur once more? We better not, right? If you liked this video, please give a thumbs up, and if you would like more updates on space, subscribe to our YouTube channel. And don't forget to click on the bell icon to not miss out on any video and to get notifications on time. See you in the next one.